Hello everyone, myself Tushyantam studying 3rd year BE Electronics and Communication Engineering in SNS College of Technology. My title is Performance Issues in Layers of OSI Model. First of all, what is OSI? OSI stands for Open System Interconnection. It is a reference model that describes how the information from a software application in one computer moves through a physical medium to the software application in another computer. OSI consists of 7 layers. Each layer performs a particular network function. OSI model was developed by the International Organization for Standardization (ISO) in 1984, and it's now considered as an architectural model for the intercomputer communications. OSI model divides the whole task into 7 small and manageable tasks. Each layer is assigned a particular task. Each layer is self-contained so that the task assigned to each layer can be performed independently. These are the 7 layers of OSI model. First of all, from physical layer, second layer is data link, and the third layer is network, and the fourth layer is transport, and fifth layer is session, and sixth layer is presentation, and seventh layer is application. And in these layers, the data is in form of bits in physical layer, and frames in data link layer, and packets in network layer, and segments in transport layer, and data in all other 3 layers such as session, presentation, and application. There are 7 OSI layers. Each layer has different functions. These are the list of 7 layers. Now let us discuss about the characteristics of a OSI model. The given diagram depicts the characteristics of OSI model. The OSI model is divided into 2 layers, upper layer and lower layer. The upper layer of OSI model mainly deals with the application related issues, and they are implemented only in the software. The application layer is closest to the end user. Both the end user and the application layer interact with the software applications. An upper layer refers to the layer just above another layer. The lower layer of the OSI model deals with the data transport issues. The data link layer and the physical layer are implemented in hardware and software. The physical layer is the lowest layer of the OSI model and is closest to the physical medium. The physical layer is mainly responsible for placing the information on the physical medium. And that's all about characteristics of OSI layer. Now let us dive into the main concept, that's performance issues in OSI layer. Analyzing performance issues in each of the layer, and it is given below. First of all, the performance issue that are present in physical layer, that are signal attenuation, cable quality, and latency. These are the things that affects the performance of the physical layer. First of all, let us see signal attenuation. As signal travel over long distance, they can weaken, leading to the data loss or corruption. Electromagnetic interference, external factors like electromagnetic fields or nearby devices can interface with signals, causing performance degradation. Next, cable quality. The quality of the cables and connectors can impact signal strength and reliability. And third, latency. Propagation delay due to the speed of light can affect long distance communication. And to the next layer, that is data link layer. The factors that affect the performance in this layer are collision domains, frame loss, broadcast traffic, duplex mismatch. First of all, collision domains. In Ether networks, collisions can occur when multiple devices attempt to transmit simultaneously, leading to the performance issues. And frame loss. Errors in frame transmission can result in data loss. Broadcast traffic. Effective broadcast traffic can saturate the network, affecting overall performance. Duplex mismatch. Incompatible duplex settings between devices lead to performance problem. And next of all, network layer. The problems in network layers are routing issues, subnetting, congestion, quality of service, often referred as QoS. First of all, routing issues. Incorrect routing decisions can lead to suboptimal paths or congestion. And subnetting refers to poorly designed subnets can lead to inefficient IP address allocation and routing. And next one, congestion. Network congestion can occur when traffic exceeds network capacity, resulting in packet loss and delays. And quality of service. Inadequate quality of service configurations can result in uneven performance for different types of traffics. Next is transport layer. Segmentation and reassembly, congestion control, flow control, connection establishment are the performance issues found in transport layer. In segmentation and reassembly, improper segmentation or reassembly of data can lead to performance degradation. Congestion control is referred to inefficient congestion control algorithm can lead to network congestion. Flow control, inadequate flow control mechanism can result in buffer overflow and dropped packets. Connection establishment, the process of establishing and tearing down connections can introduce latency. And to the next layer, that is session layer. The performance issues that are present in session layer are session establishment, session timeout, session state maintenance, mentation and reassembly. Session establishment. Delays in session establishment can impact application performance. Session timeout. Premature session timeouts can disrupt communication. Session state maintenance. The overhead of maintain state session can affect performance. Mentation and reassembly. Improper segmentation or reassembly of data can lead to performance degradation. And to the next layer, that is presentation layer. Presentation layer, the data format converting data between different formats can introduce processing overhead. And encryption and decryption. Security protocols can add latency and processing overhead. Data compression. Compression and decompression can impact performance, especially on low-end devices. And these are the high-level descriptions of potential performance issues at each layers of OSI module. Detailed analysis and mitigation strategies would require in-depth examinations of specific network configuration, technologies, and applications. The application layer. Resource utilization. Resource-intensive applications can strain system resources, leading to performance issues. Inefficient protocols can lead to excessive data exchange, which affects the performance. Next, server overload. Overload servers can lead to slow response times or interruptions. Client-server interactions. Poorly optimized client-server instructions can impact application responsiveness. Thank you.